devices that are designed to filter out. There we go. So we know that these line filters on these older machines from the 1980s that were there to protect them against dirty power back in the day, they're not actually necessary, but realistically you still install them just for safety. And what we're going to try and do tonight is replace those AC line capacitors, which are now dudded. Now, when I pull apart a machine, I always lay out the screws in a pattern. Something that I've learned in my day job. It makes it a lot easier to deal with. If you're not great with pulling apart units, highly recommend that you get a piece of paper and you actually write out and draw a little diagram to show you where all of the screws came from if you are laying them out in a diagram. Now, I've never opened an Osborne before, but as someone that's been repairing computers for the last 27 years, we're just going to start by removing all the visibles and try and kind of take this casing off of this machine and have a look at these line capacitors. Now, when you're dealing with line capacitors and anything obviously high voltage, you do have to be careful. This machine hasn't been plugged in for quite some time, over a year.
Voltage on it.
So don't have to worry about that. But if you are working on anything, you make sure that, one, it's not connected to live power. You do make sure it's grounded as well. Now, I'm not grounding this machine at the moment. Now, I'm actually not going to undo those just yet because I've got a funny feeling that those screws aren't necessary. So I'm just going to start by trying to detach this from the front. Now, I can actually see we've got some... No, we've got to take off these... No, we've got some more screws at the front, but we also have... I'll just walk around here. We've got some of these potentiometer knobs that need to actually come off to get this fascia off. And we're going to need a little, what looks to be a T5 or a T6 screwdriver, or a little... So I'll just lay these out in formation again.
We've got any torques.
So we can see that that's all coming off now, but it seems to be held in place by these two knobs. So we're going to try and remove those. So we'll just have a look what we've got.
No torques in that.
Now, I'm not one for improvising too much where I don't have to, but I should be able to use a little flathead here to undo these, because they are very small little screws. I'll just try now. I'm just loosening these screws, but that is not happening. I'll just try something slightly larger. That is too large. No, I'm not getting any traction there. I'll just have a look through my toolbox here and see what I can find. Now, we do have limited tooling down here at the ACMS at the moment, so if you have any excess tools lying around that you haven't used for a long time, or duplicates, you might have got some in a kit from a company for an install, you're always welcome to send them on down for us to put into
Well, we can come and pick them up.
workshop here. Now, just going to try again to see. They definitely need to come out. So, definitely a hex screwdriver. I'm just going to have a look in my own toolkit because they definitely look like a T5 to me. I might have one on me, but I might have actually pulled it out of my kit. So I'm just going to have a look through and see if I've got a T5 on me.
Show them around the place while we're waiting.
Yeah, you can show people around
Two
while
people
I
watching.
work on this. Yeah. So Murray's just going to
Just take you for a walk on the rest of the building. There's our 1401. Some of our cable collection that I'm currently sorting through. Odd cars in the museum.
Why don't you show people these incredible network connectors that we've located?
Oh yes, I put those on Facebook earlier.
Okay, I've now found a screwdriver that's the right size for these knobs, so we can continue on with this.
Okay, back to the Osborne.
Back to the Osborne. So we've now removed those, which should allow us. There we go. We've now got that bezel
Front cover off.
off the face of the Osborne,
Ah,
which has now opened us up. Now
torch.
that's always an interesting one. We've got just a loose thing here. I'm just going to put on some extra lights here.
That's a good idea.
Might help people see what's going on. So just a random screw that's fallen out of the machine when I've opened it. Never a good thing.
Oh, it was loose in there.
Loose
Okay.
screws cause lots of problems.
smoke.
So you can see here we've got what looks to be maybe a 5-inch CRT, and it has a little piece of plastic, a cover on it, which is actually a little privacy cover. It's got, and you can actually see the shiny CRT in front of it. This actually dulls it down. Yes, let's actually have a look at the size of this. So now CRTs, you mentioned you measure diagonally. So this one seems to be a 5-inch, or it could be a 5.5, depending on it. But 5 inches looks about right, because you don't actually get a full CRT. One of the things that I've noticed a lot of people do when they repair old units like this is they stretch out the CRT size and they drag it out to the corners. If you drag out a CRT's image to the corners of the screen, you get distortion. Most CRTs actually have a gutter of around 1 inch on them. So in actual fact, although this may be a physically 5 to 5.5 inch, your actual visible image should only be about 4 to 4.5 inches, which is standard. Okay, so now we've released all of that. We're going to have a quick look through and see what else we might need to release to get this unit out of here. Now I can see that there's meant to have been a screw there, which is probably the unit that's just fallen out, and there's another screw over here. Now interestingly enough, never having worked on an Osborne before, but the interior certainly looks like just perspex that has been heated and bent, and that everything is basically sitting on just bent or modified perspex kind of sheets.
A lot of vacant space there under the drawers.
There is a lot of vacant space there. So on that front fascia, there was 5 1/4 inch floppy drive storage slots, and a bit of room for heat dissipation too. Now you've got two, I'd say that they're 180 or 360K floppy drives here, one on each side. Quite a neat little setup. Now,
Those catches at the top.
yeah, there's still something holding us together here, and
Screw at the back in the middle.
I'm gonna undo those 2 screws at the back in the middle. I had a feeling that those screws at the back might have actually literally just been there to hold the handle, but I'm going to take a leap of faith and assume that those 2 screws are actually pinching everything together, and that I can just push through. Yeah, so that's what I'm doing. I'm just pushing through from the back now, and I'm able to push this out. Now, in our actual workshop here, we actually do have anti-static mat. I'm not going to be touching any of the boards tonight. I'm just handling it by the plastic and metal. So what I'm going to do now is I'm just going to tip this up for a second to try and shake this loose, because it's just think it's just the plastic is warped, so I've just got to gently take my time. There is no rush in vintage computing when you're restoring items. You don't want to rush. Rushing is how you end up with problems.
Breaking things.
We've now released that. Not too many dust bunnies in there. There's no other extra screws, just a little bit of debris. And now we've got access.
CRT.
So you've got the CRT tube. Now, funny enough, although it's a tiny CRT, your actual your yoke and the actual length of the CRT doesn't change too much. The length of the CRT, there is pretty much a limit because you have to cast the image. Even your 1-inch CRTs that used to use in digital camcorders from the 1970s and 80s, even those 1-inch CRTs were still a couple of inches long. Now I can see that we've got over on the side here.
Power supply.
Flip this around. The power supply is back here, and we can see that it's screwed in from the bottom. Now I can see that the way this is handwritten here, that to me looks like an Aztec power supply. This actually looks almost identical to the power supply used in the Lisa, in the way it's handwritten like this. I'm going to assume it's an Aztec power supply made in Hong Kong based on the way it's handwritten. Now we can see here that there's a 110 volt jumper. It's now installed. Now I'm just going to lean it on its side. I don't want to lean it on the face because I don't want to scratch the CRT. And we're going to unscrew. There seems to be 4 screws holding this power supply in, so I'm just going to slowly take these out. Once again, reminder, safety, I haven't had this unit charged up for a long time. If you have not worked on open power supplies before, don't work on them yourself. Get an engineer or electrician to assist you. It's not something that you kind of should be doing
Take that other
at
board
home.
off.
Now, interestingly enough, one thing that I do dislike immensely about designs like this is that I have to actually remove the main board from the unit to be able to unscrew the power supply. This is where designers of projects like this
Fail.
should have been speaking to their counterparts in other parts of the business, because simply they could have easily put a hole through the board and designed it so that you could remove the parts. The reason you want something like that is, especially on these kind of units, not exactly the easiest things to service. So you don't want to be pulling apart devices any more than you need to. And especially at that time, faulty parts were a much higher incidence back in the 1970s, 80s. You know, servicing computers, even like I've worked with Apple for a long time. Even Apple, when they first released the Macintosh series of computers and the Apple IIs, you generally got no warranty. It was literally that the unit would function out of the box, and that was the warranty that you got. Then by the late 80s, they started providing 90 days of limited warranty that you could pay to extend, and then finally in the 90s we started getting 1-year warranties, which is obviously
Pretty
where
standard.
we are now. So we've now released the board, which I'm just going to kind of gently sit. I don't want to be touching it any more than I need to get to this power supply. Now the power supply is going to be pretty easy to service on this machine. It is actually quite a tiny little power supply compared to most. And there'll be some cables holding this together, but I'm just going to quickly release it, and then I'm going to disconnect these connectors. Now you can see that there's actually, this is another poor design aesthetic. You've got 2 connectors, but in actual fact they're both the same colours, so I'm going to assume that you've got the 2 power supplies for the floppy drives, and there's actually a third there, so they look to be shared. Then we have our grounding cable, which I'm going to remove, disconnect. Then we've got our, now this is our AC input. Now one thing that scares me about this is you can see how thin that cable is. That is actually transferring 240 volts from the opposite side of the computer all the way to this side of the computer on the power supply over a less than 1 mil diameter cable. Honestly, that I really don't understand how that was ever legal. That is exceptionally bad for 240 volts of AC input that's coming into the power supply. That's actually quite scary to me. Now you can see that
6 amp fuse.
you've got a 230 volt and 115 volt pin here that have actually been, now these have actually been hardwired onto the board, which is a bit strange, because normally you'd have your 110 volt connected to the 110 here, or you'd change this to 230 volts. Now, as I said, I guessed it right, Aztec, Hong Kong, and you can see we've got a 0.1 UF 240 volt AC line capacitor there that's exploded. This is something very common through power supplies through the late 70s through to the mid 80s. These had basically disappeared by the mid 80s, these particular type, which are these reefer capacitors. What happens is they dry out, the plastic, if you can see there, it cracks, the units split, and they're little polyester caps, and they just blow out all this brown, very disgusting smelling smoke. And if you accidentally leave one running in your household and you fill it up, as I know friends have done, it can actually be quite a serious issue, and you can end up spending a lot of money having to claim insurance to get the smell out of your house. I believe that one of our members, or at least a friend that I know, accidentally, inadvertently left a unit running when they went out the shops, and one of the line capacitors broke, and it caused a massive amount of damage to their home from the smell. So I've been able to disconnect those now. The weird thing about this is normally you do just connect this for 230 and that for 110. This has actually got two cables connected, which suggests to me that there's an ability to switch the 230 to 110 on the other side of the unit, but I can't see any ability. It definitely says it's 240 only, so I don't know what's going on there. There's been some kind of modification to the power supply. So there's the Aztec power supply, and tonight we're going to replace this capacitor, and if I've got them on me, we're going to replace the 0.01 UFs as well. We've got 25 volt 1000 UFs, which I definitely have in my toolkit. Then we've got 16 volt 220/100 UF, which I definitely have as well. 25 volt 470s. I do have these. I don't know that I've got radial ones, maybe only axial, but we'll have a look. What else have we got here? We've got a 16 volt 330 UF, which I'll definitely have as well. These larger ones, generally the larger they are, the less likely they are to have failed. 250 volt 100 UF. If I've got them, I'll replace them. There's no point in not replacing as many as we can. Then we've got what looks to be a 10 volt or a 6 volt 220 UF hidden down behind here, which I'll definitely have as well. These power supplies are quite easy to work on. They've got these huge planes. Weirdly enough, the 240 volts probably has more metal running on the back of this power supply than it does through these cables, which is quite worrisome. So I'm going to stop the live feed now for a couple of minutes while I set up my soldering station on a workbench and with some work mat, and we're going to replace this power supply, put the unit back together, and then we're going to power it on and see how we go. So if everyone wants to come back in about 10 minutes, we'll see you soon. Hey everybody, I'm back here now. We've got our removed Osborne PSU here, and we've had a lot of comments on our previous video about removing this, so thanks everyone that's commented, including Serge, or Sergey, that used to work at the Osborne factory. So hello. So I've pulled out all the components. So I have these large buckets of components here from my office. We've got everything kind of on par to do repairs. So we've pulled out a number here. So what I'm going to start by doing is I like to remove one series at a time and replace them. I tend to not, unless I need to, remove all of the components at one time and do them, simply because in a lot of cases these little identifiers on them. So for instance, C6, C24, etc. Each of those numbers is a capacitor number, and then it'll actually tell you in well, not a service manual, but maybe the circuit diagrams, what each of them does. So you've got a whole bunch of different components here of different ratings. So I've got my lovely JBC soldering tool here that we have down here at the workshops that I bring down on a Wednesday. Much better quality than your kind of standard soldering tools. Will make this job really quite nice and simple. So what I'm going to first do is I'm going to remove, I'm going to do these large blue 1000 UF 25 volts. Now, to give you an idea of just how much technology has changed, so this is a 1982 power supply unit, manufactured week number 3, 1982, as seen there by the date code. You've now got, so these are 1000 UF 25 volts. This is also 1000 UF 25 volt, and you can see just how much smaller these components are. Now, when you are buying components, particularly these AC line filters, you do want to try and get case size, because you can actually buy different size case units for some components. So you actually want to make sure that you're buying the same case sizes. I know in a lot of power supplies, like the Lisa power supply that was also designed by Aztec, there's often an ability or space where there's actually multiple inputs. So it's hard to see here because I'll have to remove this piece of tape from our damaged component there that we'll be replacing a little later on. Now, I'm just going to leave that. I'm going to come back to that. But sometimes you'll actually see on these boards, it's not so notable here, but you've actually got multiple holes. And that was designed that during production, if they got a different supplier to provide components that were of a differing size, that they could actually install a different size component onto the board. It's very apparent on the Lisa boards. A lot of the components on the Lisa power supply actually have maybe like a 10 mil aperture and then like a 15 mil aperture, or a 15 mil aperture and a 20 mil aperture connected to the same plane, so that you could actually interchange between a larger component and a smaller component depending on what was available at the time from the suppliers. So what we're going to do now is I'm going to start by removing these 1000 UF 25 volts and then replacing them. So I've got 3000 UF 25 volts, 3 replacement caps. Now, just a little bit of a lesson here. You can see that these units, you can see there it says that it's 85 degrees Celsius. These capacitors were designed to run usually for 1,000 or 2,000 hours, maybe even less, at 85 degrees Celsius. When I redo my capping, I generally buy 105 degree replacements. These will obviously last a lot longer, especially when you're going through the process of recapping vintage machines. Using good quality components and doing it one time and doing it correctly, or doing it properly, I should say, is a better way to go. You shouldn't be like pulling these things apart every couple of years, because if these components blow, or you have a circuit that goes, you can end up sending voltage to a really sensitive part of the computer and damaging the computer beyond repair or beyond economical repair. So it's good to use good quality components. So once again, the reason we've pulled this apart is because of this failed AC line filter here, but we're going to start by doing a full recap and replacing all of the capacitors except for these 250 volt units. A little worryingly, this 250 volt here at the edge does look like it's got a slight, ever so slight bulge in the top of the cap there, which is usually a sign that they're starting to fail. But in this case, we're going to leave those for now. I don't have anything 100 UF 250 volts on me. I generally don't carry these, and I order them specifically. I may have ordered some for this, but I'm going to actually have to have a look in my car because the box of components that I ordered for this project don't seem to be in the box that I thought they were. So I'm going to pass the camera over to Murray so I can have my hands free. I've got my anti-static mat set up now. First thing I'm going to do is I'm going to clean my tip. You always want to make sure that before and after you use your soldering iron to clean your tip. So inside this little aperture here is some steel wool, and you want a nice shiny tip. And then I'm going to flip this over, identify where the components are, and I'm going to start removing them. So we've got 1, 2, 3. Now, the way these were done in the past, they're all pulled over on themselves, which is not great. Makes it very difficult to remove, but I've got desoldering braid here, which is my favourite little thing. Got to be careful you don't burn your hands, and you don't want to be huffing too much of the solder off these devices either. These are all old devices, use lead in the solder, so you want to be a little bit cautious. I normally do have an extraction fan, which I will bring in next week to actually kind of suck off some of the fumes and filter it, because you don't want to be huffing lead. So what I'm doing here is I'm sucking in the solder from around the legs so that I can try and remove these components without tearing or damaging the board. A little bit difficult in this case because the caps have actually been folded onto the board, which is not something that we would do today. We would just put the legs straight through. So I'm pulling the solder off the board. Now everyone has differing ways of doing this kind of work. I have very much gotten far more used to using desolder braid now for nice clean jobs, but if I'm being quick and I'm not too fast, or I know that the boards are kind of like, these are large boards, I'm not really worried about damaging them, I'll actually usually just heat the pad and wiggle the component out. Now, I'm sure people will have an opinion on the fact that you shouldn't do that, but realistically, it's a great way of removing the component if you're not worried about saving it. And then I've removed the component. I can now use a bit of the solder braid to just clean up the aperture there so that I can feed in the new component without any problems. So you can see there, as I was saying before, you've got one aperture here, you've got 2 over here. So this board is definitely designed to take multiple sized components. So you could have a 5mm diameter between your legs on this, or a 7 or 8mm if you use the larger slot over there. So because our components have dropped in size perfectly, we're now going to be able to move down a size here. You can actually see the leg size is much narrower. Now, the other thing I've got to do is just checking the board here. If you do have a leaking component, and this one actually has been leaking a little by the looks of things, you may end up with some electrolytic here on the board. So the best thing to do is actually wash that down with a little bit of isopropyl alcohol, which I'll do in a little bit. There's really not much here. It looks like it might have leaked a tiny bit many moons ago, but I will clean that up just to ensure, because the electrolytic that leaks is conductive. Obviously these devices are designed
Corrosive.
corrosive and conductive, so they're gonna, get stuff, and you don't want that just sitting on the board because it will actually short circuit things. Very common on stuff from the late 80s and early 90s. So once again, hitting these up and just wiggling these out. Once again, everyone has a way that they do stuff. I would not do this on any kind of modern electronics. I only do it on a board like this, where you've got these massive tracks that don't have,
Soak up the heat.
that can soak up the heat, and also some boards from this era have these small, especially with the Lisa boards, have these in the VDUs, have these small metal discs around the actual components, and if you damage those, it's a real pain to work on. So they're the kind of boards that I will completely desolder, potentially use a desolder station and do it perfectly, rather than kind of do a little bit more of a rush like this. And once again, this is a personal item. I'm still going to do a good job because I want this to last, but you know, I'm not going to go crazy. Now, you can see, yeah, both of these components have definitely leaked a mild bit. So they're obviously still working because this power supply was still functional. It was just blowing smoke because of that blown out component. But I'm glad that I am doing this, because when these components start going out of tolerance and start doing the wrong things, that's when you can start putting power through the wrong places and causing some serious damage. As I learnt recently, I had a Apple Profile hard drive on my Lisa go out of spec, and it blew out both the control card and analog card on my very rare 1982 5MB Lisa hard drive, which are obviously not very easy to come by and repair once that kind of damage is done. And I'm still working on that at the moment for my Lisa 1. So now I've got that, we've got all those apertures open, cleaned up. So what the next point is going to be, I know that we've actually got the smaller apertures here, so I'm going to just clean those up so we can access them. It looks like, weirdly, they've given us the narrower aperture at the bottom two here, but not on the top one. So the design of the board is different. There's actually another hole there, and there we go, there's another hole there. So those components actually, they'd actually completely designed the board differently, but these are much smaller components. Just to give you once again an idea of just how much of a change we have here. There's our 3 original 1982 components with our 3 modern components. So I'm just going to clean my tooltip again. And the best thing about the JDC, I put it in there, the temperature is going to drop from 385 degrees, which is a pretty good temperature for old leaded products. It's going to put the unit to sleep. It's going to drop it down to 150 degrees. And then if I walk away and don't use the machine for a while, I think it's 5 or 6 minutes, it'll drop it to 20 degrees so that my tips don't get damaged. It's one reason I love these devices. If any members do want to invest in a device like this, they're somewhat around the $750, $800 mark, but the ACMS members do actually get a wholesale price on them. So if anyone's interested, you can reach out and I can put you in touch with our distributor who is aware of the ACMS and will give you a good price. So now that I've got that there cleaned up, I'm just going to get some tissue and alcohol.
Tissue's over there.
I will use
Meanwhile, a word from our sponsor.
yes, a word from our sponsor, but no.
Got any
Now,
New South Wales vouchers left?
Yes, if you've got any New South Wales vouchers left, don't let the government reclaim them, use them up.
2 days to go.
Now, once again, I would normally not use a tissue to clean an electronic like this. I would use
hand
liquid
sanitizer.
isopropyl and use Q-tips. But I stupidly don't have any on me today, so I'm just cleaning that all up. Got the board nice and clean there. So now what I can do, and there's no residue, because we definitely don't want any residue under there, we're going to load our components in. Now, it's really important, you got your plus signs. So we've got a plus sign to indicate positive, and on your caps you've got a negative. Now the one thing is, on radial and axial capacitors you'll have this nice line with the net for the negatives. When you're using surface mount capacitors, the line or the black mark is positive, which gets very confusing if you're kind of new to this, and you've got to be careful that you don't accidentally blow your caps up. So I'm just installing these now in these smaller aperture holes, which are beautiful that they're on this board because they're perfect for these components. And I'm installing them the right way around, and I'm double checking. So I've got my 25 volt 1000 US. Nice, and you can see all that extra board real estate. And what I'm going to now do is, just like they were before, I'm just going to bend the legs, which I don't necessarily like doing, but it's actually adding some strength. That's okay. I am going to just grab my leaded solder here, and I am going to put these in. Now, while I go and recharge my camera, we'll come back in a little while. So we're back, everyone. So I'll just quickly give you a bit of a tour. So the power supply, we've replaced all the components here, the 3 AC line capacitors there. We've left the large 220, the 100 UF 250 volt caps for now. I'm just tucking away this cable that was just kind of hanging there in the back before, which I didn't necessarily like. That's the old 110 volt connection. So now that that's all been cleaned up, you can see I could use a little bit more flux to flow that metal, make it look a little bit nicer, but it's definitely all well and truly in there, except, no, that's definitely in there. It's just a pitting on it. So I'm going to install this power supply now. So we're just going to have Murray hold that for me while I refit this power supply. So we're going to reconnect our connectors here. So
No.
We had the third one was
I thought the other one
was open. Then we've got our ground connection here, which we can
check your old video just to be sure.
No, I've got a photographic memory. And we've got our AC input here, which just clips on nicely. So we've got those, and then these two cables come over here. So we've got our 230 volt connection that I'm wedging on there, and our 110 for some reason. They're both connected in the 230 volt, which is unusual to me, but it is what it is. It's obviously been working. So, and funny enough, these cables are very rigid, very unusual. So there's obviously a bit of solid copper in there, which is probably a good and a bad thing. Now, I can now sit our power supply back into the unit. So I'm just going to
Underneath.
gently put this back in. No, it sits on top. Okay, so we're now back in. Now they've put this pad here just to make sure that you don't accidentally zap the 240 volts. It doesn't arc to the main board. And we've got
Fingers, I think.
our screws here, which have got insulating discs on them to obviously protect it. And we've got one grounding screw that grounds the power supply to the chassis. And you can tell the difference here. Once again, I've laid out my screws so I know where they all go back in. One recommendation I have for anyone doing any kind of restoration work is, once you're finished for the night, no matter where you're up to, put the entire unit back together. You don't want to be pulling things apart constantly, but the longer you leave something open, the more likely something's going to go wrong. You're either going to damage it, you're going to lose something, or you're going to forget how it was put together, which is the worst thing that can happen. It's something I have been guilty of a lot in my lifetime, and I finally learnt that I always try and get all my components together well and truly before I open up a device. I make sure that I've got all the tools handy, which I can't really say there were tonight, but think we're very close here, because it's just very easy to lose items. You know, you leave something, even if you've got it all packaged nicely into totes, etc. Anything can happen. You can get hit by a car tomorrow, you can get sick, you can have something else come up in your life, and that happens all the time these days. So you just want to make sure that everything's back together, so that if something goes wrong, you can just persist. Okay, so that's all nicely, you know, back together now. So what we're going to do, and this is a little bit of a struggle, because we've got this little back panel. I'm just going to wipe down because it's looking a bit dirty here. And if I just wipe it down while it's out, we'll get rid of that kind of staining. If I was, you know, restoring this in full, I would likely, you know, potentially sand this down, get rid of some of this metal and repaint it, or have it dipped if I really wanted to go crazy. But anything with stickers on it like this, I will try and leave together. Now these are a very interesting design here. You've actually got this panel here that covers over the 240 volt connection, it covers the fuse, and then you can actually open the fuse and cover over the 240, so that it's a safety issue. You can't touch the fuse while it's plugged into power, and then you've got your power plugged in and you can't access the fuse. Nice little, you know, design aesthetic there. And you can see here too, they've used these pads on the back of this power supply to stop the screws from going through and touching anything they shouldn't. It's just really basic design, but it obviously does the trick. So now we've got this unit, and I've got to remember which way. So we've got the two screws which are at the top of the unit.
Yeah,
so
it's got to go through there.
The fact is, we need to actually install the power connection inside the machine before we can actually flip the unit over and install it. So I'm just going to flip this over now, and I've got to be very gentle with this, because I just don't want that glass coming off the CRT, which is just being held on by a prayer at the moment. I'm going to take this unit through to the back, so I've got to just hold that in while I screw this back together. I'll just get one of these . Nice and squared, and now I can start tightening up those screws. You want to obviously tighten them just enough. You don't want to be cracking, especially older plastics. This is a particular some kind of weird formed vinyl or plastic blow. It seems to have worn pretty well, but you can see that the fire retardant in the plastic has made it go this yellow colour. The original colour would have actually been close to this sticker, so it would have been a light grey colour, and it's gone this kind of yellowed colour. Now, just going to go back through and just make sure that all my screws are nice and just tighten up. Okay, and then I'm going to lift the unit and gently, making sure that I'm not pinching any of the cables, slide it back in. And take my time again like I did when I pulled it to pieces. Get the handle to get through the rear housing correctly. tape by time to get
Yeah,
this
that's
through and aligned. Put these two large screws in the back to hold it in place. And realistically, this is all we're going to need to do. We don't need to put the base on to test it.
ah, you want a power cord,
No,
don't you?
we'll take it back over to the workbench.
Ah, yeah.
Okay. So I'm just going to carry this across the workbench. Okay, I'm just going to steal my power cable here. You can see all of the old components there wrapped up.
Can need room for your keyboard.
We'll need room for the keyboard, so I'm just going to... We don't need the keyboard to test, but we might as well see if the
Seeing as we
keyboard
got it.
is functional. Now obviously one thing that I need to be wary of here is if I've changed the brightness settings. The other thing is just obviously using earth leakage and other detectors. So once again, working on 240 volt, always be careful. So we'll fire this up. And we have something happening.
No smoke yet.
There we go, we've got video. And we'll just do some adjustments, and you can see our tiny little screen here is just coming online. The focus is a little bit poor, so let me just fix up the brightness. Usually with a CRT, you do want to give it some time to actually heat up. To ensure that you get the best, most accurate picture. But there we go. We've got our Osborne 1 from 1983. 1983 was a great year.
Really?
I was born in 1983, so it should have been a great year. Okay. So I think we're going to have to do a little bit more adjustment to get that screen nice and crisp, but it's pretty good. And the fact is, it is not blowing smoke. So we have a great unit here now ready to go. It's saying insert disk and drive A and press return. I'll just hit return, and we should get it to. It should start reading the drive, but it's not. So chances are
Put a disc in.
well, it should still read, but it's not. My guess is that it's not particularly happy with the keyboard, and we'll probably have to look at the keyboard at a later time. But
Or one of those
good news
connectors is in the wrong spot.
well, it should have been 3 connectors, 1 for the hard drive and 2 for the disk drive. So we can now turn this off, and we have successfully restored the power supply in this Osborne 1. So thanks for watching, everyone. Hope you join us next week, where we'll hopefully be recapping a Macintosh, I'm assuming, next week. So, or 2 weeks, I should say, yep, in a fortnight. So there we go, Osborne 1. So we're going to finish this up, we're going to seal it up, and I'm gonna take this back home, and I do have some discs for it, so I can try and fire up and see if we actually have any action on that floppy drive. Thanks.